Hello friends, today we are going to discuss the mode 2 of 8255 and its name is strobed bidirectional bus input and output. So, so in this mode, first of all we should know that this mode is only applicable to port A. That means group A of 8255. We know that all the ports of 8255 is divided in two groups. One is group A and second is group B. So this mode is only applicable to group A. And in group A, only port A is used here to transfer the data. So basically port A is used as bidirectional data port. Okay. So we can either transmit or receive an 8-bit data using port A. And as port A will be used as data transmit and receive, so in order to maintain the data flow, 5 bits from port C will be used here to maintain the data flow of bus. So here is the characteristics of 8255. Let's see. So this mode is used in group A only, and one 8-bit bidirectional bus port, that is port A, and a 5-bit that means it will be from port C, control port, and both inputs and outputs are latched. That means a memory element will be present in between 8085 and peripheral device, where first of all data will be stored and then after it will be transmitted either to 8085 or to the peripheral device. Then 5-bit control port is used for control and status for the 8-bit. Okay, and we can also check the status of the control bits of port C. So this was the main characteristics of mode 2. Now let's see the working of mode 2 in 8255. So here in this diagram, this is the port A that will be used as bidirectional data port. Okay, and these are the 5 bits of port C that we will use in order to control the transmission of 8-bit data on port A. So these are PC3, PC4, PC5, PC6 and PC7, and the role of these pins are written here in front of those pins. That means PC3 will work as INTR. It means an interrupt will be sent to the 885 microprocessor using this pin. PC7 is OBF bar, that means output buffer full, and PC6 is ACK acknowledgement. These two pins will be used when we are going to configure the port A as an output port. If we are going to configure port A as an output port, then we will be using these two pins. And in order to use these two pins, or in order to set port A as an output port, we also should enable the flip-flop that is here. It is INT-E1. So in order to enable this flip-flop, we will have to write a 1 at PC6 by using bit set reset mode. Okay, so what is the role of these pins here? When microprocessor wants to send some data to the peripheral device, so first of all microprocessor will send data to the 8255, and after getting the data from microprocessor, that data will be stored in the output latch. As we know that the inputs and outputs are latched in the 8255, so that output data will be stored in the output latch of 8255, and as the data will be stored in the output latch of 8255, in order to inform the peripheral device, 8255 will send a 0 logic here on the OBF bar pin, and this 0 logic will inform the peripheral device that a data is ready in the output latch of the 8255 to receive by you. And in response of this signal, the peripheral device will send a 0 at this pin, that is ACK bar. This is acknowledge pin. It is an acknowledgement from the peripheral device to the 8255 that yes, I know that data is present here in the output latch and I am going to read that data. Then next is PC4. This is STB bar, that is strobe, and PC5, this is input buffer full. These two pins are used when we will be configuring port A as an input port. If we will use port A as an input port, then in that case we will be using these two pins of port C, and the role of those pins of port C are written here, that is STB bar and IBF. So now in this case, a peripheral device will write some data here on the port A, and as this peripheral device will send the data to the port A, peripheral device will also send a 0 on this pin, PC4 pin, that is strobe pin, and this 0 signal will put the data present on the peripheral bus into the input buffer of the 8255, input latch of the 8255. And as the data will be inside the 8255, in order to acknowledge the peripheral device, 8255 will send a high signal here 1 on the PC5 pin, and that will work as IBF, input buffer full. It will inform the peripheral device that yes, my input port, that means my input latch, has got data sent by you, and do not send the next data. Okay, and this will be informed by 8255 to the peripheral device by putting a high logic here on the PC5 pin, that is input buffer full pin. So this was the role of these pins. Now we are going to see how the communication will take place. So I have shown three blocks here. One is 805 microprocessor itself, second is 8255, and third is bidirectional peripheral. That means this device is able to transmit as well as receive the data. Okay, and in order to either transmit or receive, this will be connected to the port A of 8255. This is port A of 8255 through peripheral bus. Okay, so now we are going to understand first of all when port A will be used as input port. In the bidirectional mode, first of all we are going to configure port A as input. In that case, what will be the sequence of the data flow? So first of all, data will be sent to the, or data will be put on the data bus of peripheral. Okay, that means data will be present here. I am writing it as 1. This is steps. So in first steps, data will be put on the peripheral bus by the peripheral device. In second step, in order to inform the 8255, this peripheral device will inform the 8255 by putting a 0 on the strobe pin, STB bar pin. So first of all, peripheral device will send the data, and in order to inform that I have sent the data, it will put a 0 on the STB bar pin, and this 0 on the STB bar pin, it will cause this data to be latched into the input latch of the 8255, and now 8255 will have that data inside the 8255. Then in order to inform the peripheral device that okay, I have got your 8-bit data and now do not send the next 8-bit, so it will, in response to this STB bar, this 8255 will send a high logic on the input buffer full pin, and in response to this input buffer full, after a certain time, this STB bar pin will be set on the high level logic by the peripheral device, because its work was to inform 8255 that I have sent the data and to latch the data into the 8255, and when the data is present with the 8255, then there is no need to put a 0 on this pin. Okay, so after this, after certain time, when STB bar is on the high logic and input bar full is on the high logic, and if we have also kept the INTE1 on the high logic by using bit set reset mode, okay, then all of these three pins are at high logic, so 8255 will generate an interrupt request to the 8255 by using INTR pin. Okay, so after that, a subroutine will be run here. 8085 will run subroutine to read the data present on the port A of 8255, and for that, in the subroutine, 8085 will put a low on the RD bar signal. That means in between the subroutine there will be a time when 805 will keep 0 on the RD bar pin in order to read the data present at the port A. So this was the total sequence that I explained you in the case of when we are configuring port A as input. So remember the steps. First, data will be kept, then STB bar signal will be sent, then in response to STB bar IBF signal will be sent, and after certain time an interrupt will be sent to the 8085. In response to that, subroutine will run here and 8085 will send 0 on the RD bar pin. So let's see the timing diagram for input. So let's understand this timing diagram. So first of all, this is one. This is peripheral bus and the data is sent on this bus by the peripheral device. So here the data is present on the peripheral by this device. Okay. Now as the data is here, so after certain time peripheral will inform the 8255 by sending a 0 on the STB bar pin. So here is the STB bar pin. I am writing it as 2. So after the data that was present here on the peripheral bus, after that STB bar pin put itself on a 0 logic, and this is to inform the 8255 that I have sent the data. And in response to that, 8255 set 1 at the IBF pin. So you can see after this transition, after that a transition is occurring on the IBF pin. I am writing it as 3. So on the IBF pin, after this transition, after certain time, this is going to high logic from 0 to 1, and this transition from 0 to 1, this will cause the STB bar pin to go on 0 to high. That means it will again set the STB bar pin. This logic, this transition is setting this one. Okay, so as I said here, so these are the 3 sequences, and after certain time STB bar pin, this is on the high logic and IBF is already on the high logic, and we have already written INTE1 using bit set reset mode to the high logic. So an interrupt will be generated, and that here is that interrupt request. This is INTR. Because in mode 2 input and output both the diagrams are mixed here, so it is like this here. Okay, that means same INTR is used for input and output, indicate both the things, but you can draw a separate interrupt signal in order to show. Okay, so I hope this must be clear to you. Then when an interrupt is generated, then after certain time, so I am writing it as 4 because this was 1, 2, 3, 4. After when interrupt is generated, after certain time, microprocessor will read the data present at the peripheral. Okay, and when microprocessor will read the data, then the low on the RD bar pin, this will clear the interrupt here. So after this transition, when RD bar will be from high to low logic, it will come to the low state. INTR pin will come to the low state, because if this will not come to the low state, then when RD bar will be again high, then it will cause again an interrupt. So in order to avoid that interrupt, this signal will return to the low logic, and when this RD bar signal will go from low to high pin, then this will clear the IBF pin, because IBF is indicating that no need to send the data. 8255 is saying to peripheral that no need to send the data, but when IBF is again clear, that means when the logic at IBF will be 0, then it indicates that now peripheral can send the next 8 bit of data. So this was for input only. Next we are going to see that when we will be configuring port A as output, then what will happen there. So again I have made the 805 microprocessor 8255 and bidirectional peripheral device. So in that case, as we are going to configure port A as an output port, that means data will be given to the bidirectional peripheral by the 8255. Okay, so first of all 8085 will write the data to the port A. So remember the sequence. I just want to make you understand the sequence here. So first of all, data will be presented to the 8255 by the microprocessor itself, and then this data will be stored in the output latch of the port A, I am writing it OL, you must understand this as output latch. So when microprocessor has written the data to the output latch of the port A, then in order to inform the bidirectional peripheral, this 8255 will send a low signal on the output buffer full pin of peripheral device. This will indicate the peripheral device that yes, I have some data that should be received by you, and in response of this signal, this bidirectional peripheral device, it will put a 0 on this ACK bar, that is acknowledgement pin, to inform the 8255 that yes, I have received your message and I am going to receive the data byte store here. And then after certain time, this will be on one logic, this will be on one logic, and INT1, this will be on one logic. Then it will send an interrupt to the 8085, and that interrupt will say that interrupt will inform the 8085 that now this peripheral device is again ready to receive next byte of data. So now let's see the timing diagram of this when port A will be configured as output. Now port A is configured as output. Okay. So this timing diagram will start from here. First of all, just a minute. Yes. So first of all, microprocessor will write the data. So that's why this timing diagram is starting with WR bar signal. Okay. So a low on WR bar pin, this indicates that microprocessor has written data to the 8255. Okay. And when that data will be inside the output latch of the port A, then 8255 will send the 0 on the output buffer full pin of the peripheral device. So here, after this, OBF pin will go to the low logic, okay, after this transition. So this is indicating to the peripheral device that yes, a data byte is present in my output latch, so please read it. Okay. Then in response to this, an acknowledgement signal, this is here, it will go to the low state by the peripheral device. So a low here indicates that yes, peripheral device has got the message. This was 2 and this was third step. So peripheral device has got the message that yes, an 8-bit data is present to the 8255, and logic change from high to low here, it will change the logic of OBF from low to high here. So this transition will set the transition here from low to high. So because of this, the OBF bar signal will return to the high level logic. Okay. And as 8255 will got a low on the WR bar signal, it will immediately put the status of INTR on the low logic. So you will have to remember this, that anytime if a WR bar signal changes from high to low logic, so because of that, INTR will set to the low logic. Because if this will not set to the low logic, then it will again cause the interrupt to the 885 microprocessor. So this is I can write 4, but okay. So finally, after certain time, we have got OBF on the high logic, ACK bar is also on the high logic. So these two are on the high logic, and we have already written INT1 flip flop on the one logic. So that will generate an interrupt, okay, to the 8085. And remember that interrupt will be for next byte, because when ACK bar is high, it indicates that yes, peripheral device has received the data. So after receiving the data, the interrupt is generated for the next byte of the data. So basically this was the mode 2, where port A is used as input as well as output. Okay. And in order to control the data flow, that means at a time a port A will be having input data or output data. So in order to control the data flow, 5 bits from port C are used to control those data that we have already seen here. Okay. So This was mode 2. And one more thing, that as we are using only group A here, so group B is still available for the communication, so we can use simultaneously group B in either mode 0 or mode 1. Okay, so this was all about mode 2 of 8255. And one more thing, that if you are not using PC2 comma 0 1 2, those 3 bits of the port C, then you can use those 3 bits as input or output, okay, by using bit set reset mode. So this was all about 8255 mode 2. And if you like my video, then please press the like button and also subscribe to the my channel. Thank you.